Firstly, an apology, but, and there is a big but to all of this, when the chip came in, I couldn't resist it, couldn't wait, changed it out and removed it from the board, as you can see in this picture. Then I switched it on and tried it, and as you can see, the little green light flashed. And now my first thoughts was hurrah, and fixed it, but the green light seemed to be flashing slightly faster than what I remember, although my memory is pretty vague on that side of the subject. Luckily, I've got another one. Let's take away the one that's been repaired and talk about this one. I powered this unit up, the green light started flashing at the same rate as the other one. I thought, great, job over. Blinked my eye about 10 seconds later and the green light stopped flashing. We now have a fault on this power unit, and I'm going to take you through finding the fault on this one. I won't speak too much, I'll just get on with the job. I bought this unit second hand and it worked just fine, and primarily it's for our guest when she arrives, save her bringing her power charger with her for her electric wheelchair. And secondly, I bought it because it was a very reasonable price. And thirdly, I bought it because it allowed me to check out the component values for repairing the other power unit. And we also have a sort of a third unit which she has at home. So she's got a main unit at home and a spare one in case anything goes wrong. And now we've got one here for when she visits. Most power units sort of break down into sort of the same format really. We've got mains input, either side of that we've got two fuses, one there, one there. There's a varistor there. Varistor is meant to take out sort of high voltage spikes. There's the choke which goes either side, live and neutral. And before the choke though is normally a capacitor. This capacitor, you probably can't see it there. Let's turn it around so that you can see it. This capacitor here. And after the choke, it goes off to the bridge rectifier. And this bridge rectifier here, just in front of it, is a small ceramic capacitor, which I think is there to take out high frequency interference generated by the power unit. And behind that, on the rectified side, is another varistor stuck there. Now, and the circuit looks a bit like, let's see if we put the circuit in front of you. The circuit looks like this. To test this, all we need to do is just go to here or here and check here and here and see what we got. So without further ado, let's get on with it. I'll turn it over because it's easier for me. Switch my meter on if we can get it into a nice position. Diode mode. There's one side of the mains input, and over here is these two terminals of the bridge rectifier output, and on one of them it's open circuit, and the other one we have a diode drop. Now if I swap over to the other side, you should see that we've got the diode drop again, which indicates that all's well in that direction up to that point there. Now swapping the polarity of our test probes over, I put plus on here, you will see that we now have an open circuit to that point there. Go over to the other terminal output of the bridge rectifier and get the voltage drop. Bring our test lead over to the other mains input and we get the voltage drop there. Nothing there. So basically speaking, we can forget about that bit of the circuit. Now, from here on it becomes difficult because we don't have a circuit diagram, but we do have a recommended circuit diagram I came across for the chip that I replaced in the other unit. And although this is a very simplified circuit, there are a few major points in here that are very similar to what we find on our power unit that's blown. And as you see, we've got this RF filter bridge rectifier circuit here, and it runs off to a transformer and a switching transistor, which is MOSFET, and a 0.1 ohm current sensing resistor. Now, these three components are common on our power unit. And also is this diode that runs off from where they take the power out. In fact, the diode's common, and the electrolytic capacitor performs a similar sort of configuration. Well, firstly, this is the transformer that we were talking about, the across here, and this is where all the main power goes to the outputs that charge the battery. There is another transformer over this side, and this is used to derive the low voltages required to drive all the logic function, the integrated circuits here. So there's two functions. One's providing the 24 volts to the output, and the other one is providing the necessary voltages to drive these chips and transistors that sort of decide upon which charging rate we're going to have. So basically the circuit breaks up. The circuit breaks up at this component here. So it's a good point to actually test across. Now, when we did the repaired the other unit, we had the, let's see if I can find a diode. I'll take these components out, some of them, not all of them, just these. This is the diode, and that was blown. Let me show you, put it on a sort of resistance value. Let's see if we can see what's what. So it's 0.2 of an ohm. Not very much, is it? Or 0.1. And it's like a lump of wire. Right, let's see. Both sides. Yeah. Right. So, in my opinion, a good starting point is going to be to have a look at that diode and see whether that diode is still functioning. And from experience and replacing it on the other unit, I know exactly where it is, and it's exactly these little leads here and here. Let's bring more meter in so you can see what's going on. Here and here. And lo and behold, it's 1 ohm. Now that don't bode well for anything. And I think this is an excellent point to actually break the circuit into two halves. So we sort of keep this all the voltages for this transformer, all the circuitry for this transformer on this side of the diode, all the circuitry for that transformer is on that side of the diode, and we need to take this diode out. Now here comes the hard part, and it's what makes this job difficult. The diode itself, get in the camera, well, you can't see it, and you won't be able to see it because you see the thickness of this heatsink. It actually sits underneath, directly underneath this heatsink on the board down here, and we need to remove the 3 transistors here and the heatsink to get access to that diode. What a bind. But it does have its plus side, and it means that we can test these 3 transistors when we're done. So we've got to remove the heatsink and sort of decouple these, should say desolder these transistors, which are sort of those 3 there. There. We've got to sort of desolder them from the board and make sure the leads are decoupled from the board so that we can get on with our repair. Hope that's clear. I'll shut up and shut up for a jiff while I set myself up to get on working. Now from here on, guys, it's going to get a bit sort of hectic, and life is quite difficult because they use lead-free solder, and we need to try and get the temperatures down on some of the points before we desolder them. And to do that, we're going to use leaded solder, which is the sort of normal trick. And one of the tips I would say before you do anything like this is to sort of before you start sort of melting your your leaded solder onto the blob, is to see if you can get it molten first. And if you can't, as I can't here, my solder chip is not sort of hot enough to melt that. And currently I'm sitting at 230 degrees. I'm going to take it up to about 250, 260, no, yeah, 260. So the problem is that as soon as you touch a cold surface, the heat is conducted away from the tip of your iron, and it's a question of whether your iron can supply enough heat to replace, to raise the temperature up. So basically heat is being conducted away faster than it's getting to the tip, and that's why I've had to increase the temperature. We'll try again and see what happens. And now we're sort of molten, but it's sort of not molten. It is molten, but it's not molten. Now I'm going to whack this up to, which is very unusual for me, to around about 310 or so, and I'm hoping to get the, we're dealing with a board that's relatively, sort of relatively thick, probably 1.2 millimeters thick, and we're dealing with a heat sink. It's aluminium, so the heat's really being conducted away, and I want to get the solder that I add to get mixed and go right down. So here we go, and see what happens. Make sure we got that nice and molten now, and we'll add our leaded solder to it, and that should work. And we'll do the same with this one. And you see what I mean? It's taking time for the chip to heat up again, and we should be in business. And heat's getting through. Give it a little time. Now add our solder, and that should work. It's not going to drop the temperature right down to the same temperature as this melts out, because the eutectic won't be a perfect one for that application, but it'll drop it below it's roughly, with ours here it's 220, and we're going to drop the temperature down a little bit. Anything helps. Now right, here we go again. Add our solder. Keep going. Now, that's a lot of solder there. And well, do the same with this one. It's molten. Add our solder. It gets all the way through. Right, now I'm going to keep it there. Now I'm going to use some solder wick to get rid of most of the solder if I can. Seems a bit sort of daft, but that's the way I'm going. Right, let's go. Let's see how much of this we can get out. And I'll do this one first. Let's see what we've got. Not getting very far, are we? And you've got to allow yourself plenty of time and don't sort of be a butcher at it if you can avoid it, because you want it to all go back nicely eventually. Yeah, better check that one out. It's difficult, isn't it? And this is because these little lugs are sort of a funny shape. They're oblong shape, and it makes getting the solder away difficult. Let's see that now. Okay. Now, I've got to settle for that. I'm going to add a little bit more solder again, which seems a little... No, I won't. No, perhaps I will, perhaps I won't. I'll have to switch on another tool now, which makes a noise. And the object of the next tool I'm using is just a solder sucker to get rid of a bit of the bit more of the solder. I'm going to try the lugs to start with and see whether I'll get anywhere. Not even touching it. Let's see about these. Not even getting close. Barely. Barely. Right, we'll let that fester. Not easy. And this is why we have to sort of try to decrease the temperature of the... Now that's gone to sleep. Wait for this to warm up now. There. No, I put that on there too early. Try that one. Patience is a virtue, but with this, honestly, it does sort of test one's patience. And as you can see, that little lead has got to come away a bit. I need a tool to try and make the bond. Let's see. Yep, that leads free. Yeah, free. I've just got to try and get the others like that. Let's see if that one's free or not. Now it's really stuck in. It's still stuck. See if we can get that moving. Sometimes it's just requires a little bit of help. And you sort of hope it doesn't sort of seal again. This one looks like it's stuck again. Nothing for it, but sort of put a little bit more solder on. Get our solder, have another go. Well, hopefully you can see that. Yeah, that one's looks good. Now for the next one. I think we'll put a little lot more solder on it. Come up here. Here we go. I'll feel it's loose. And we'll see if that's loose. Now we repeat this process on the other three and on the other two, and I'm going to stop it here because just wasting video. Now I'm back, and that was a little bit more traumatic than I was hoping for, and it's never an easy job. One, my solder sucker got stuck, and as you can see some of the bits and pieces that came out of it, so I had to unblock that. And although a solder sucker works extremely well, it does get blocked quite easily, and so the time it saves you over some other techniques is offset against the time you spend unblocking it, and horses for courses. But I prefer it much to the sort of pump thing that you just go plop with. They're useless. I haven't got one in my toolbox. And now I've got to get these lugs unsoldered. Now, I don't know whether it's possible to get my iron, this thing, tool over these lugs. Let's see. No, they're not going to go over them, which is unfortunate. And in a future time I'm going to remedy that by making my own chip and make a slot in it as opposed to sort of a circular hole so that it can get over lugs, because that would help an awful lot then. So I have to resort to another technique, and I've got a broad instrument here. It's a chisel. It's fairly blunt, and if you're worried about it I would put a piece of tape over it to stop it from sort of doing any damage on the inside. And I'm going to put that in there and heat the lugs, and then once the solder's molten, just twist, go up to this one, do it. Just watch me, hopefully it'll work quite neatly. Temperature of the temperature of the soldering iron up again and running. Yeah, good. Okay, not yet. Nice and warm. Gently put this in I don't want to stab anything inside, and you'll see. Right, walked it up a little bit, waiting for it to cool off. Walk it up a little bit, wait for it to cool off. Wait. Not working too well. Try the other one. Wait for it to cool off. Come back to this one. Twist. Now it may be that the components of that transistor are holding it in, and we'll check to see whether they're free or not. If they're not free, that's what our problem is. Yeah, they're all free, so not too sure what the problem is. Have another go. Oh dear. Weird. Right, come around the other side. Have another go. Walking the lug out. Molten. Yeah, there we go. One. And cool off. Every time you do something in front of the camera, it's sort of, somehow or another, it just turns out more difficult. Put that in there. Yeah, molten. Walk it up. Probably out almost. And let's make sure. Let's see what this happens. Up. Oops. 3. And this one. 3. And there. That's 3. That's 3. That's 3. Not quite. That's 3. The one stuck in is this one. Why this one? That's 3. I think it's 3. I'll just sort of wait for it to. There you go. That's 3. Is it through the other side? Yeah. So, you see how we got that out. I'm resetting my temperature of the soldering iron to what I normally have it at, so I don't make any mistakes in the future. And this one is still slightly, oh no, there you go. So that's out. It took a little bit of doing. I've got to take, I want to take, I'm using that there to prop it up. I want to take out this diode, and it's going to be a bit, probably, I don't know, I won't say tricky because I don't think it is tricky, but the leads are bent over, so using the solder sucker on it is a little bit problematical because you're going in at an angle, and it's best done if you can make good contact. Again, we'll dab it with a little bit of solder to set the ball rolling. I happen to know where the diode is, so I know which one to sort of treat. Again, the soldering iron bit is dirty. I'll put a bit of solder on now. Needs to be cleaned. Re-tinned and warmed up as soon as it sort of gets molten, and it's not melting because there's too much heat being conducted away from the tip. Put a bit of oil in there to help, and we'll put some in here to help. Now can we succeed? I have no idea. I tend to sort of like to push the lead up with my soldering iron, like so, and do the same this side, if I can. All about getting it molten. If you can't get it molten, you can't push it up. There we go. No, we're going to be doing that for about a day. Get the other iron out. See if we can do the same on this one. Alright, let's sort of get those leads up nice and straight. Now, on this diode, they're rather, because it's a bit of a power diode, it's sort of thicker leads on the thing. I'm going to put a little bit more solder on to sort of see if we can reduce the temperature a bit more. Okay, and give it another go with the solder sucker. And try this one. I think we're not there really, but let's see if I press the bomb there, and I can't press it down. Right. Press it through the soldering iron. Not going, is it? Damn thing won't go. Right, bung this up a bit. really, it's during this sort of process you can do a lot of damage to the PCB tracks by having your iron up too hot and end up lifting them if you're not careful. Okay, well, I managed to sort of press the lead through, and I'm going to try and put my solder sucker on top. That'll do. I'll have to. And we'll go over to the other side, see if we can get it out now. Got a lot of those pliers there. Well, one edge out. And a combination of the iron and pair of pliers. There we go. Oh, dropped it on the floor. Unfortunately, the markings on the board allow you to know which way around to put it back in. Switch these suckers off. Reduce the temperatures of my soldering iron. Let's have a look at this diode. Okay. Right, we're in diode mode. Oops. And it's 0.5 across the diode, one direction. And 0 across the other. So that diode is actually okay. That component is okay. But we took it out to sort of divide the circuit into two so that we could see what was what's broken and what isn't. Right, we've got our meter in diode mode. We'll go on to our first MOSFET, which is I know it's an N-channel MOSFET, so drain, source, nothing. There. Right, now this one is on. Let's just switch it off. Open. Switch it on. Well, broadly speaking, that one seems to be working. Am I right to assume that these are going to be N-channel? Let's read the numbers on them first. Well, on both of them it says that in IRF 644, and I'm going to go and check to see what they are and come back. They are N-channel MOSFETs, IRF 644, and we'll just see. It says 1 ohm, and that says ridiculous. Do that again. Oh, these are blown. So they've got to be replaced, and I think that's game over for today. But we've got to ask ourselves the question, what caused them to blow? And I'll come back to this board. And we've got this little piggyback board in here. It's the other piggyback board, so the one I repaired on the other one was here. This is another one. I think we'll desolder that and take that out. And then off camera I shall start testing components, and if I come across anything I'll explain it later. I was hoping for it to sort of desolder better than that. Perhaps there's one instance where we might use a bit of flux. Now, I'm not happy with my homemade flux. I think that it's sort of evaporated a lot of its isopropanol that was in there, and I don't think it's flowing very well. Mind you, a little bit on here will help. Let's go. And burning off and leaving a horrible residue. And that is because it's too rich in rosin, I think. It may be the varnish on the board that's causing the problems, but I don't see much damage from where I've been doing all the desoldering, so I presume it's the flux. And well, I never used to do that. I think it's just the concentration of rosin and alcohol of just too rich in rosin. 5:1 seems okay. A little bit more. Right. Now we should be able to remove that board. And out she comes. I didn't think I was going to like that method of mounting the bolts, but I'm quite chuffed with it. It works well. Easy to put in place and easy to desolder. Right, well, that's it for today. Now to go and find some replacement components. One last thing about these boards, they're uneconomic to repair in that they take too long to sort of disassemble, and also the replacement transistors and that tend to be a little bit on the expensive side. There's no guarantee that what I've done will work forever and a day, and if it all blows up again, then I'll go out and buy a less expensive, more modern power supply to do the same job, and they are out there and available. But I'm not giving up just yet, so we'll come back to this after I've sourced some transistors and checked it all out for everything else. It's almost 2 weeks later, and it's taken a week and a half for the components to get here in the post, and it's the silly season for the post at present. And before we go any further, I think it's best to sort of try and clear out these holes first and make sure everything is going to fit. I know we're upside down, but these will never go back in, straight in, and it can be a very frustrating job getting them back in. So we're going to clean these little tags up and make sure we clean the holes out. The cleaner these are, the easier it's going to be to get them into the board. As you can imagine, I've got my soldering iron turned up to a fairly high heat, which is about 300 degrees. It's all a little bit meaningless, it's just got to be hot enough to do the job. And I've got that cleaned off. Flip those over. Do the same this side. There we go. a little bit more heat into that. Okay, and we'll clean this one up. If you're having trouble, sometimes a little bit of flux will help too, but when it comes to reassembling it, it's going to make our life a lot easier when we have to locate all the pins in the holes on the board, that these little lugs fit precisely and easily into the PCB where they belong. Just check the inside of the little lugs. Well, they seem to be okay. Just give that on. And I think that'll be alright. We're not picking up much solder, but because there's so little on there already, so there we go. That should be okay. On the board, these two holes are relatively clean this side, and we can use those to test to see whether our little lugs are going to fit them nicely. And as you can see, they slide in quite nicely on that side, and they fit nicely that side, so there's no problems there. Now these two holes are still blocked, and sometimes it's very difficult to de-wick them, and if you're having trouble, a method that I use is to take a little bit of solder wick. In fact, I prefer to use a slightly fatter one. And I really need to get my flux out, but first of all I'm going to just pinch it together like so, sort of wiggle it around, so make it round. Dip it in the end of the flux, which will make life a little bit easier, or should do. And then I'm going to poke it in the arm, and hopefully it'll go in. And I really ought to put my magnifying glasses on, see what I'm doing. And feeding it into the arm, and hopefully warming up my solder braid. Perhaps it didn't work as nice as I like, it has done for me in the past. Cut that bit off. Do what I did before. Cut that bit off. And I think I'll tin it. Bit of solder. And one of the reasons I'm having trouble is I haven't got the soldering iron bit that I would prefer to be using. I'm not letting that stop me. Let's see if it'll work on this one. We're in the hole. There we go. Get well into the hole. There we go. Nice clean hole. It's just I do it this way because these holes sometimes don't de-wick by going across them. Sometimes they do, sometimes they don't. We're now going to try and see if these lugs fit into the holes. If they don't, we'll have to carry on clearing them. They're fitting nicely now on that side, and those fitting nicely there. We need to replace these two mosfets, and they've sort of pinched into location, I think. Let's undo that. Okay, take it right out. Well, that's strange. There we go. And the next one. Both of them are gone. I've never seen them fitted in this way, and I think it's a nice way of, oh I see, it's the little pin on the back there that's isolating it and making it difficult. Right. But I quite like the idea. The new ones, let's get one out. It would be wise let's just check that they sit on there okay. Yeah, not quite as nice as you would hope. Why is that? Oh, I see. That's cleverly done. It's on an angle there to sort of make sure that when you tighten up you are really clamping onto that. That's clever. We need to bend the leads to match as exactly as possible the, oh god, that one's gone already. Try this one. To match the prongs so that they locate a little bit easier in the holes when we come to put it back. Well, that all fits nicely, so we can now take that out and proceed with what we were going to do. There's a little board that fits in there, and I'm going to talk about that for a couple of minutes. So let's move that out of the way. This little chip drives the two MOSFETs that we've just replaced, and it switches them both on and off simultaneously. And now I checked the outputs of this chip, and they don't seem damaged. And from the MOSFET drive of this chip, they go through two little sort of networks. This one here, and I think that one over there, that do some sort of voltage protection towards between the gate of the MOSFET on the board and the MOSFET drivers on this little chip, and all seems well. The problem is I don't really know how the two chips are functioning on this side of the board, and all the components that are around, the diodes, the Zener diodes, the small transistors, we've got one or two on the board, they're transistors I believe, and oh no, perhaps they're Zeners. Well, let me put it to you this way, I'm satisfied that none of these components are blown, but I don't know entirely whether this is okay and whether these two components are okay. So I've got a bit of an ego, and I'm quite prepared to try soldering it all up now and giving it a go. I've not found any components faulty other than the two components I've just changed, and although with one exception, and it is sort of niggling me, and soon back out. And hopefully we can see inside here. There's a diode that goes across there. It's the one we removed earlier. Although this is tested okay, I've just got a gut feeling that I want to replace it, and I managed to get replacement diodes for it. But again, they're new old stock, and I just got a gut feeling that this is the trouble. I don't know why. I'm probably way off beam, but you've got to go with your instinct in these things. And I'm changing it for one of these little things, which are basically speaking the equivalent of that, but an SMD device. And we need to get one out of its packing. Here we go. I'll come back when I've finished that, because it'll just be hours of silence. Unfortunately, the memory ran out in the video camera while I was soldering this lot back in, and there's nothing to see. But it's only soldering. Now I'm just going to clean up the board. I'm itching to find out whether this works or not, and MOSFETs, in my opinion, don't just blow, they blow because something causes them to blow. And what that was, I really haven't discovered. I've changed this little diode out, which is went on the other board but hadn't been gone on this one. I've tested all the components, everything that I can test, I've tested in this area, and I can find nothing wrong. On the small piggyback boards that are in there, and let's take that out, in there, it's not possible to sort of work out whether the integrated circuits that are on those boards, whether they're fully functional or not, and they may be the culprit for the fault, and if so, this is going to blow up again and going to be a little bit costly for me. And if that happens, then I will have to buy the integrated circuits for these little piggyback boards and try them out. Now, why am I going to do that is because I want to really identify the fault. Just a bit of personal pride really, more than anything. But it may work, it may not, I don't know. But once I've plugged it in, we'll find out whether it does work. Yeah, this is the other end of the power lead, so I've not got that plugged in because I don't want to go touching this once I power it up. I get this horrible feeling it's going to blow up on me. Right, we're all plugged in. And here we go for the moment of truth. If it works, the green light will flash. If it doesn't, it might go bang. If not, if it don't flash, it just go bang without going flash. Right, well, green light's flashing. That's about how long it flashed before it blew up before. We've gone past that. I want to stick my fingers in and feel for warmth, but don't, because it'll end up killing me. It's very, very dangerous at this stage, so for goodness sake, keep one's hands away. Don't go prodding anything, otherwise you will end up brown bread. So I really want to test this out thoroughly before we plug it back into any electric wheelchair, because that was terribly expensive. I don't want to go damaging that in any way, and but we're moving forward, which is a good thing.